everyone, and welcome to another episode of AWS Partners Unplugged. My name is Igor Alexeyev, and I'm your today's host. AWS Partners Unplugged is a podcast series where we discuss all things related to partners. In this episode, I welcome our guest speaker, Ayan. Ayan, would you like to introduce yourself?
Sure, Igor. Thank you. Happy to be here. My name is Ayan Ray. I am a partner solutions architect, and I work as a specialist in the field of generative AI.
And generative AI, of course, is a very popular topic, and that's what we're discussing today. So let's start by maybe you talking what kind of generative AI trends you're seeing. I know everybody wants to go from POC to production. What are your thoughts on what's going on currently with partners and customers?
Yeah, the interesting thing about my new role is that I get a chance to work with many partners and joint customers. There are few common questions that I always face. And the most common question is, Ayan, there are so many foundation models to choose from. How do I choose a model that best fits my use case? Enterprise use cases, you know this better than I do, Igor, are extremely complex. And sometimes these use cases are very niche. Now, as an AWS representative, we have always believed in model choice. We strongly believe that not one model will rule the world. That's why, as part of Amazon Bedrock, we have a choice of high-performing foundation models from leading AI companies, along with a broad set of other capabilities that helps our customers to build and, more importantly, to scale these generative AI applications. Now, I encourage my partners to always evaluate the foundation models on their specific use cases. And in that regard, very interestingly, we launched 2 new features as of this last reInvent. Both of the features are in preview. First of all, we launched a feature where customers can use LLM as a judge to evaluate generative AI applications, and that is part of evaluations in Amazon Bedrock. And the second feature that we launched in preview is to use LLM as a judge for evaluating RAG applications, and that is part of Amazon Bedrock knowledge bases. Now, customers can evaluate their RAG applications. They can evaluate the retrieval part alone. They can evaluate the retrieval and response generation, and they can also evaluate the generative AI application from the lens of responsible AI metrics. So I think that's an exciting feature for customers, and this, I strongly believe, will help to instill more confidence in their generative AI applications and will in turn help move their POCs to production. Because, even if I compare this with traditional programming, none of the code moves to production without testing it.
Yeah, and testing, I know a lot of developers are used to deterministic outcomes, right? You run your unit test, your requested input parameters, whatever, and you expect the same outcome every time. Not the case with generative AI applications, right?
Yeah, that's make this evaluation bit more complex, and that is where this new features of using LLM as a judge can really help. The challenge is the generative AI application's output is stochastic.
Right.
It gives random output every time, but those outputs might be similar in meaning. Now, it is very difficult for a rule-based engine or a human being to evaluate that. The other challenge is that not always customers have good quality label data sets for evaluation. I think both of these combined is what makes this evaluation really challenging when it comes to generative AI applications, RAG, and agentic applications.
Yeah, and I like how you mentioned that you need to evaluate on your own data, because every day we see new statistics published, new rankings.
Yeah.
And models are fluctuating, some in the top, some drop off a little bit. The models are released by AWS. We will show that reInvent, Nova, new family, had very good results and very reasonably priced.
Yeah.
You mentioned also RAG evaluation, and of course everybody knows what retrieval augmented generation is. What is happening in that space more recently? How these applications are evolving?
Yeah. One thing, TLDR, is that RAG applications are maturing. We are moving beyond just simple use cases. And there are few different things that's happening in this space. First of all, there's a quest to optimize the retrieval time. Now, because we need to retrieve the responses fast, the context window is increasing, and we are retrieving more data from these vector databases. So if you think about it, right, these vector embeddings are of usually 15366 dimensions, and all these vector embeddings are floating points, which means 32 bits. Now, when we do a similarity search on it, it's a very complex matrix multiplication, and we are comparing the input embeddings of the input prompt with that of what is stored in the vector databases. So it's like, each of these embeddings is of 32 bits. The quest there is, what if we can reduce 32 bits to int 8? That will take 8 bits, and which will more interestingly, this will reduce the memory footprint to a great extent without compromising on the fidelity to a great extent, right? That's what's going on the retrieval optimization side of things.
And I want to chime in. Yeah, definitely latency is a big concern for great user experience. People want responses fast, and there was some improvements, right?
Yeah.
The streaming of the response, you can get like first couple of words sooner.
Absolutely.
But quantization is the ultimate, solution, where you reduce the size and it takes less time CPU to process it. Actually, I've heard it firsthand, like the first embeddings models were rolled out. People are like, yeah, great models.
Yeah.
And then, 2K, but then, hold on. If my record is 1K in a database and I have 2K more, I have 3x storage now on memory that's been taken out by the embedding. And it was not clear that they needed those 2K. And then it's not clear if the precision is needed, of the 32-bit.
Yep.
At the beginning, people were not looking into that. And I guess that's where RAG is going right now. We are looking for more and more things to do with the application. What beyond the quantization, what else do you see?
Yeah. The other trend that I see is RAG moving beyond just unstructured data. That is, the data is data. Data is stored in various different forms across enterprises. Sometimes it is stored as unstructured data, sometimes it is stored as structured data, sometimes in columnar databases, and also sometimes in graph databases. So as of last reInvent, Amazon Bedrock Knowledge Bases extended support to Amazon Redshift, which can cover the data that is stored in columnar data stores and data warehouses, and also extended support to Neptune DB. That means you can also now combine the data that is stored in graph form. So I think that's what's going on. This combining data from multiple different sources is another area that's increasingly becoming popular. This is all helping to solve more complex use cases. Let me give you an example. Like, say you are looking for a house and you want to search townhomes near Apple campus, near Apple headquarters, and you want townhomes which also has a private backyard, has a barbecue area. Now, if you think about it, it's actually a combination of three different things. Townhomes, searching for townhomes is a keyword specific search. You are very specific in what you want. Expressing an intent that you are open to have a private backyard, barbecue area, you are a fun-loving person. You might also be open for a spa, jacuzzi, clubhouse, etc. So you are expressing an intent. That is exactly where semantic search shines. Now you're also saying, give me townhomes or show me townhomes within 10 miles from Apple headquarters. Apple headquarters is in Cupertino, California. Now, within 10 miles will require a specific geospatial search. Semantic search here alone won't be sufficient to figure out, hey, which properties from neighboring areas of Sunnyvale are within 10 miles from Apple headquarters. That's where these complex hybrid use cases are coming into play.
Yeah, and in fact, This was a big confusion in the beginning when generative AI scene exploded. People equated generative AI application with semantic search. But in fact, it's not only semantic search. It's sometimes a direct lookup can be enough. I usually give example. If you have a banking application and need to respond about your particular situation, they shouldn't be searched for Igor semantically.
Yeah.
It has to be an exact key-based lookup. And I like how you approach the problem. This is a domain-specific situation, and the knowledge sometimes can be represented by vector search, semantic search, can be sometimes maybe direct lookup.
Yep.
Maybe a particular chunk of knowledge can be retrieved using graph, right? Because maybe it's geospatial, because your answers or your domain is only within certain space, and outside of the geo-fenced area, the answer may not make sense. Pretty sure there are some other ways to go about it, but which AWS services are kind of starting to support this? If you can talk a little bit about that.
Amazon Bedrock Knowledge Bases is a great way to help customers on RAG applications. It supports vector databases, which includes our native vector database, OpenSearch, and it also has support for our partners, MongoDB, Pinecone, and Redis. We have also extended support to cover data warehouses with Amazon Redshift, and also for graph databases with Amazon NeptuneDB. So I think Amazon Bedrock Knowledge Bases is a good option for customers to build their RAG applications.
Of course, yes. Yeah, Bedrock definitely takes care of ingestion of the knowledge. But I've noticed, beyond knowledge bases, beyond RAG, recently people started talking about agent and agentic behavior and agentic applications. Let's talk about agents.
Yeah, agents are the next step after RAG. The interesting thing about agents is tool calling or function calling aspect of it. That is, you can call external APIs. Now you are not only limited to your knowledge bases. You can execute actions using internet. So there are different agentic patterns that are coming up, like hierarchical agentic patterns or different smaller agents working as a team, trying to come up with a decision and trying to come up with a consensus. So that's what's happening. We recently launched support for multi-agent orchestration as part of Amazon Bedrock Agents. So exciting things going on, and people are also using agentic solutions for agentic RAG, creating agentic RAG, which is calling an external API to grab that information and take an action using that information.
And I just want to add a little bit, because agents can sound a little bit confusing, but I think the way it started, people realized that certain actions are easier to express deterministically. A good example is calculator. Trying to teach a model to do arithmetic is a hard task.
Yeah.
But writing a simple calculator can do arithmetic plus minus division. Very easy. It's 5 lines of code. So that's how agents emerged, where agent will decide which tool to use, and that tool can be coded explicitly. And by adding agents to the generative AI applications, you enhance capabilities of the application. But you mentioned the agent flow, right? Yeah, agent flow. This is becoming more important, I think, because complexity. We now have more agents, and sometimes a model can string several agents together, perform a lookup. Let's say, give me Igor's balance, right? And calculate his mortgage payment, right? From one agent can look up my financial situation, but the other taking that as a output, taking that output and pushing it into another agent to do the mortgage calculations. And I think that's why we're slowly seeing the LangChain has this, and I believe it's a LangGraph application, right? But also Bedrock has similar capabilities as well.
Yeah, I'm seeing many partners exploring about agentic solutions. I'm seeing the integration of the no-code, low-code partners building solutions for specific use cases using agents, Bedrock agents. People are trying out to take the agentic concept and take it to respective domains, whether it's HR, whether it's marketing, whether it's sales, and creating customized solutions for a specific domain.
I love this idea. It's basically our data and analytics partners can focus on creating specific agent tailored to their storage engines and analytics engine and expose them to be used in other and generative AI applications. Awesome idea. One more trend I'm hearing recently a lot, reasoning LLMs. And to me, LLM is basically a random number generator. Well, a random string, but what people are doing with reasoning LLMs and what is it?
So the base for that is the generative AI use cases are evolving. It is evolving beyond just mere conversational AI assistants. I think industry is exploring more complex use cases in cybersecurity, data observability, which can be solved using the generative AI capabilities or using, more importantly, the reasoning capabilities, just like a human brain reasons. For example, identifying a combinatorial attack pattern in cybersecurity or figuring out vulnerability on day zero. It's very challenging for even a rule-based engine or even traditional machine learning to do so. That's why the reasoning capabilities comes into picture. These are AI models which are designed to mimic human-like reasoning, enabling them to analyze information, make inferences, and solve really complex problems. So the technique that is used, they use reinforcement learning through chain of thought to mimic the human reasoning capabilities.
That reminds me, like my daughter, when she was in first grade, they started with one-step problem, and you solve it in a single step, and then there was becoming a two-step problem where you need to derive something to solve the overall problem. And it looks like where models are following that approach by breaking complex problem into a series of smaller steps and chaining these steps together to accomplish the task. Sounds like there are rankings based on reasoning alone, right? And that's, I guess, what was the recent announcement for DeepSeek model that got published. It scored higher in the reasoning rankings. Can you talk about a little bit DeepSeek? And I mean, we cannot skip that topic. It's just
It's too big to be ignored now. The DeepSeek models really performed in math reasoning. It's the benchmarks are really promising if compared to the leading LLM providers. So DeepSeek R1 interestingly has it has the code is there, it has open weights, and also more interestingly, it has also published the methodology it used to optimize on the training, and that's all public information. So it's an evolutionary step, I would say, in the field of generative AI. The techniques that they have used, especially the rewarding model technique of GRPO, Group Relative Policy Optimization, which is, I think, according to me, is an evolutionary step in this whole LLM and generative AI field. So DeepSeek R1, I think I'm also facing a lot of partners and customer interest for DeepSeek R1. We have extended support for DeepSeek R1 as part of Amazon Bedrock. It is available in Amazon Bedrock Marketplace. This is DeepSeek R1 671 billion parameter model. The same model, the DeepSeek R1 671 billion parameter model, is available through Amazon SageMaker Jumpstart. It's also available as part of SageMaker Unified Studio. Now, DeepSeek R1 also has several distilled versions of the model.
Yeah, before you jump distillation, I want to mention that we will include the link to the announcement in the notes.
Yeah.
But yes, I did want to talk about distillation. I wanted to ask you, you mentioned that DeepSeek published their methodology. Was distillation part of their methodology when they created those models? And what is distillation in general?
So DeepSeek R1 is the 671 billion parameter model, and they have published several distilled versions of the model, which are smaller models. I'll shortly come to distillation. And there are Llama and Quen versions of the model. Also an announcement that the distilled Llama versions of DeepSeek R1 are available on Amazon Bedrock through custom model import. You can also run them on AWS Trainium and AWS Inferentia. So what is model distillation, to your question? So model distillation is the process of transferring knowledge from a more capable advanced model called as a teacher model. For example, let's say DeepSeek R1 671 billion parameter model, and transferring that knowledge to a smaller model, which is called a student model. In this case, the distilled DeepSeek R1 distilled Llama 6 billion parameter model, which is faster, which makes the small model faster and more cost efficient because it learns from the learnings of the teacher model. And to transfer knowledge, your use case specific prompts are used to first generate responses from the teacher model and then use the teacher responses to fine tune the student model. So this is distillation.
And when you say cost efficient, you mean it's cheaper to distill the model than to train from scratch, I assume? And it is cheaper to do inference because it's a smaller model, requires less compute.
Yeah, both. Because now you are distilling a smaller version, which is 6 billion parameter model, which takes up much lesser inference time compute from a higher version. So the performance can match up to a higher model for a specific use case. Now you are distilling the model. You can also distill the model for specific use case. Say, for example, you can distill a smaller version of the model for cybersecurity or for observability or for analytics. I think then it can match up to the performance of a higher parameter model, but at a much lesser inference time compute cost.
And how can partners take advantage of this technique on AWS?
As of last reInvent, we launched model distillation as a feature in Amazon Bedrock in preview. I think that's where partners and customers can come in, use the models, use the teacher models, I think Anthropic, Amazon, Nova models or Meta models to distill smaller versions of the model of the same family for their specific use cases, right? Which will be more cost efficient and it will yield better result in terms of price performance ratio.
Exactly, and that was the promise of DeepSeek. When they released their model, it's not as costly. That's completely free, but it still provides good quality responses. So for partners, it's a no-brainer to start using them. So we talked about distillation. Are there any other techniques that model providers use to improve their models?
Yeah. So the other technique that's being used is synthetic data. So if you look about distillation also, right, we are giving a certain prompt to a teacher model to generate soft labels from it, right, or to generate a chain of thought reasoning outputs from the model. So in a way, it's also synthetically generated data. Also, synthetic data is important because there are a lot of data on the internet, but not all the data is high quality data. And while saying that, I'm sugarcoating it. I think when you are building a model on this high volume of data, it leads to a very beefy model with high number of parameters, which in turn takes high amount of compute, both to train and also to deploy this high parameter model. That's the second aspect to it. And the third aspect is, even with so much data, there are still gaps within the data. For example, for scenarios like, say, earthquake, there are no, it will probably occur after several years, and we do not have any data today for earthquake. So, but we might have some gold copy of the data, even for predictive maintenance kind of scenarios in factories, right? We don't have all the data corresponding to the faults occurring. So we start with a seed data or a gold copy of the data, and then we generate permutations and combinations for various different scenarios based on that gold copy of data, which in turn improves the accuracy of the model. That's why synthetic data generation is another technique that model providers are increasingly using to improve the accuracy of the base LLM, and a technique that can be used to fine-tune the model and increase its accuracy. And you can use the LLMs available in Amazon Bedrock to synthetically generate data.
Yeah, and in fact, I want to jump in. This technique is actually coming from machine learning. And a while back in my machine learning days, we had exact same situation.
Yeah.
Customer gave us some images, and at that time we didn't have generative AI large language models that can extract easily data from images. He gave us like 1 or 2 images. He said, okay, and you need to train a model based on this to recognize this input and extract something from the image.
Yeah.
So what we did is just generate random drawings that are similar to what the customer gave us, and that was enough to train the model, and the model started recognizing.
Yeah.
And I guess the same technique migrated towards LLM now as well.
Absolutely. Image makes it more interesting because the variance in the data is even more, right? I mean, if you think about it, even in a handwritten text, it can have so many variations based on the handwriting. So that makes it even more significant to synthetically generate data.
Great. And we are coming closer to the end of the show now. I think we've covered a lot of things today. We talked about RAG evolution. We talked about most common problems, why people are not moving to production with their POC. We talked about reasoning. We talked about distillation. We talked about synthetic data, of course. I know you've written a blog. We will add it to the show notes. Anything else you want to cover? Or maybe how can people reach out to you?
Yeah, people can reach out to me on LinkedIn. My name is Ayan Ray. You can search me on LinkedIn with Ayan Ray AWS. And I'm happy to have conversations. I can go on for days on this topic. And if you are interested in any specific topic or you want to know more about other topics related to generative AI or what's happening on generative AI at AWS, I'm happy to speak about it.
Absolutely. Thank you, Ayan, for coming.
Yeah.
Thank you, everyone, for tuning in. Until next time.
Thank you, Igor.